All right, we're gonna give you a couple more minutes. Go ahead and try to download this Python script, try to run it. See if you can get anywhere with it. Yeah, for sure. And then we can just, it's 5, right? So let's give him 2 more minutes. Let's see how this goes. This is gonna be good. I'm excited. Okay, and then yeah, just open up our.
Oh, she also say. Wait, what the fuck?
It's up. There.
On the Discord, there's also a Nix Workshop channel if you guys want to ask questions there.
I think since you guys are in person though,
yeah, just raise your hand and
yeah, or just shout them out. Yeah. Have some fun. Let's just give him 2 more minutes. Why not, right? Looks like at least a couple people are trying it, so we'll see what it goes.
Oh, I see the camera.
The what?
Like, I want to see what the camera view looks like.
Sure. No, it doesn't show you. It's good enough. It's just like this area, so you can walk anywhere. You're good.
I want to see what it looks like for us.
Hey, y'all, if you're just coming in, go ahead and download the script. Try to run it. We only got like 2 more minutes left, though, so. Like 1 more minute, whatever. It's fine. What is the next slide? Make sure, but let me close my slide.
Yeah, ask them.
Yeah, I got this. It's gonna be good. All right, guys. It's been 5 or so minutes. So let's just do a show of hands. How many people were able to get the script running? Is anyone able to run it? Okay. Who's running into errors right now? Trying to run the script. All right, y'all want to tell us what your errors are? Let's hear it. Yep, that's one of them. How about you? Right, it probably does have something to do with your Python install. Anyone else? Anyone else got any errors they want to share? The point of this exercise, right, is that this sort of thing isn't so easy. This is a very, it's a Python script that looks very simple, but when you actually look at it, it's pretty evil. Even a basic Python script. So right here, let's just go to the top, right? We're importing NumPy and pandas, 2 very basic Python packages, right? You see these all everywhere, right? These are only a year old, version 1.15, version 0.23, just a year old. But did you know this version of NumPy cannot be installed on macOS anymore? A year ago, I don't know, they were doing something that literally cannot be installed anymore. In fact, Ben, if you want to demonstrate it, if you try to install NumPy 1.15, we'll download a zip, try to build it. It's pretty exciting. It spits out about 30 pages of red text and then fails. It's actually impossible to install on modern macOS. For some reason or another, something's broken. All right, switch back then. Let's take a look at the code. This version of Pandas, also more sinister than it looks. Pandas relies on NumPy for a lot of number processing stuff. So oftentimes when you try to install a version of Pandas, it uses a different version of NumPy in turn. So really there's 2 versions of NumPy. They don't like each other. Stuff doesn't work well. Now, let's keep going. We have a print statement with a format string. Format strings were only introduced in Python 3.6. If you have an older version of Python, it doesn't work. You'll fail on that one. Now, we've got this for loop. You might have read the comments. Back in NumPy 1.15, just a year ago, this statement creates a copy of this NumPy array. So if you try to change it like this, the changes actually don't go through. If you use any version of NumPy that's older than this code fails to work. And then down here, talk about df.consolidate. Yeah, that function no longer exists. If you're not using this version of pandas, this function doesn't work, and this script fails. And finally, there's one more thing. One more thing that a lot of people don't think about. Right here, we're using a shebang to run the script, right? User bin and Python tree. So it's supposed to go to your Python tree. But what about the people who don't have a user bin? Right? Do we have any Windows users here? Yeah, Windows doesn't have user bin. You can't run the script like that. It doesn't exist. It makes an assumption about the operating system that just isn't true. So how do we solve this? Well, Nix is a really good way to solve this type of issue. And let me show you guys what it looks like. So basically what Nix is it's a package manager. It's very, at the very base level. It's a package manager like apt or brew, right? These package managers that you've heard of, it's sort of like that. But what's really cool about Nix is that it provides a declarative dev environment for you, which means that there's one file. Let me show you guys what this file looks like. We have this file called shell.nix. We'll talk more about this later, but this file declares exactly what the development environment for this Python script should look like. So if I use Nix shell and I enter, maybe I'm not in the right folder. We'll get there. If I enter the shell, so I'm going to tell it, hey, I want to use this shell, this development environment. Now, assuming it loads, skip a second. Works like a charm. Everything works. And if I put this shell.nix file on any other person's computer, this script will run exactly like this. So how does that work? Well, Ben, take it away.
So the funny thing is hello world is not really a trivial thing to do because of the very first step. You have to go download the compiler interpreter for your source package. So if you want to write hello world in say Rust, you can't just write main.rs and then expect it to work. You have to go and find the Rust compiler. Maybe it's followed by Homebrew or Chocolatey or apt, RPM. There's a myriad of package managers out there. And this is assuming that it's actually been packaged for your operating system. If you're using some weird exotic combination of libraries, you may have to fix some of the compilation issues yourself. Or maybe you have to do it from source because no binary exists. So actually the very first step of downloading the compiler or interpreter is called software deployment. You're trying to get software working from one computer to work on another. And this is actually the root cause of many issues in software development. So you might have encountered these errors in various forms. For instance, incomplete dependencies. You often get DL linking errors on Windows or dynamic linking errors on Linux or Mac OS. There's incorrect assumptions about file system layout. Maybe there's user/bin/bash, or maybe there isn't one. There's incomplete, inexact dependency specification. So maybe you actually need Python version greater or equal to 3.6. And you didn't specify such a dependency. You said Python 3, for instance. And it's often not possible to mix and match versions of dependency. So if you have, say, OpenSSL, like version 1.0, and another package relies on version 1.1, oftentimes package managers will just override whatever's most recently requested OpenSSL, not caring about if it will break another existing packet. So we have component interference because dependencies aren't isolated. They inhabit the same namespace, often in the file system. So this is a big issue for when you're trying to work on multiple different projects in multiple different languages, and you don't want the conflict in any way. So Nix resolves every single one of these issues. It allows you to completely specify your dependencies exactly. It allows you to isolate your components so they can't interfere with one another. It doesn't make assumptions about the file system layout. In fact, when you take it all the way to NixOS, the only thing in user/bin is env. There is no user/bin/bash or GCC that is often found in distros like Debian. So how does it work? Well, conceptually, a package is just a function, a pure function. If the inputs are the same, the output should be the same. So the inputs are exactly the dependencies for your package, and the output is something called a derivation in Nixline. So this is like the raw build instructions, which get past the Nix builder. So this includes things like your operating system, what shell interpreter to use, the dependencies, what environment variables you need to set, and so on. So you have all this machinery that goes on in the Nix package repository. And at the end of the day, you get a derivation. And this is exactly what gets checked. You hash a derivation, and then you get something called a Nix store path. So if we can take a look at type which Python. So you can see here which Python 3, you have a store entry. So Nix/store/ this cryptographic hash is a hash of the derivation of the Python 3 expression, right? So if you change the derivation a little bit, let's say you use a different compiler, or you change a hardware flag or some hardening flag, or you maybe modify the source code of Python in a certain way, the derivation hash will change accordingly. So it cannot interfere. You can't interfere two different versions of Python that are slightly different in some way, right? And because we have this cryptographic hash, you can do something called substitution, where instead of building it locally, you can just ask a build farm, hey, I have this derivation, I have this hash, has this been built on your server? And if so, it just sends it over to you and allows for complete deployment. So you get essentially caching for free because you have this exact way to specify what the package is. And elaborating on this further, we have a bunch of other benefits. So if you produce the same derivation, you don't need to rebuild because the exact same derivation results in the exact same hash, exact same path, right? And any change downstream will recursively affect packages later on. So if you change something in OpenSSL, everything that depends on OpenSSL, at least if you make it depend on your patched version, will be rebuilt as a matter of necessity, because you can't ensure that if you change some deep dependency down, it won't affect things upstream. Right. So, and from a usability perspective, we have this interesting dichotomy where things either work everywhere and always, or nowhere and never. So you're not going to have a project where, oh, it worked 6 months ago, now it's not working, or it worked a year ago, and it's not working anymore. You can literally re-enter your project from 1.5 years ago, and things will work exactly as it did before. You also get an immutable system. Because we have this system where store paths are immutable, you can't accidentally break things by installing a different version of Python or NumPy 1.15 and so on. You also get reproducible development environments. And this just comes for free from the fact that we can track precisely what dependencies of our software project is needed. And also, this is all achieved without containerization. So maybe you guys have heard of Docker. So this is a containerization solution to this dependency problem. And essentially, it sort of hides the issue of dependency management behind another file system layer. So you're pretending to be kind of like a VM, conceptually. And that introduces performance overhead. There's issues like you can't access serial ports on Docker because there's no privileged access, among other things. So it's very slow on macOS, but Nix does this completely natively on macOS and Linux. And you can have a choice between building from source or getting from binary cache. You can mix and match as you please. And you can also get different versions of packages just by changing the build recipes very easily. Right.
All right. So what a lot of people say, this is I think what really sold me on Nix. I'm a pretty new Nix user too. I just started a couple of weeks ago. But what's so interesting about this, right, is you hear about these package managers, right, on like Ubuntu or on Debian, right, apt, right? Everyone's heard of these package managers, right? Or Homebrew, right? People know about these, especially like apt on Debian or Ubuntu. These are seen as kind of like the gold standards of package management. It seems like everything's on there. And what's really interesting is Nix has way more packages than them. They're way more up to date. These right here, so this is Arch Linux. Down here is Ubuntu 16. This is number of packages in the repository and how fresh they are up here, so how up to date. Ubuntu 16 is down here, 18 is down here, 20 is down here. There's some Raspbian stuff up here, Raspbian and Debian. That's all. Nix is up there. Nix packages unstable, has far more packages, and they're far more up to date than literally anywhere else. If you want a package in your development environment, Nix has it for the most part. Stable up here, unstable up here. It's far more powerful and far more up to date than nearly anything else.
The funny thing is, even the stable channel, which was cut 6 months ago, is still more up to date than AUR, which is rolling release.
So now we've talked to you a lot about conceptual Nix stuff, right? So now it's time to talk about use cases. I'm talking about when Nix is actually useful, and we're going to show you some demos, show you guys, how useful this type of stuff is. So the first thing is developing Python. So actually, I think what we're going to do first is let's walk through this file. So yeah, Ben, here you go. Take the stage.
All right, so this is a Nix expression. So Nix is a purely functional language. So think of it like JSON with lazy functions. So actually, this is exactly the functional model I was talking about. These braces indicate that these are arguments, and this expression after is the return value, right? So it takes arguments, Nix packages or packages, there's default arguments here, and here we specify exactly the commit of Nix packages to use. And we just import it, it's a package set. And this is a Nix way to create a shell with a Python that has in the Python path NumPy and pandas. So this is how you can declaratively say to Nix, I want a shell whose inputs are Python with the following packages, NumPy and pandas, and exactly from this commit. So when you run Nix shell, it evaluates this and then gets the output and launches you into the shell where it will always be reproducible because we specified exactly which commit to use. Again, I put emphasis on this because infamously Homebrew has things like what's it called? Cast files.
Oh yeah, Homebrew actually has a lot of issues. A lot of people use Homebrew on macOS. The big issue when you start using it, and this is something I run into a lot, is on Homebrew, you can't install a version of a package. You can only install the latest version. So if you have something that depends on an older version of some package, right? If you need, like PyQt4, right? Or you need like some older package, you just can't get it anymore because it got built years ago. Now it doesn't build and they don't provide it from cache. You certainly can't build it from source. You're screwed. Can't do anything. Can't build it. With this, we're pulling packages, right? So this commit is like what the package repository looked like over a year ago. So we're going over a year back and we're saying, give me the packages based on what they look like here. And it can just do that. All those packages are cached. You can pull any point in time. So let's actually talk about how it can be even easier than this. You don't even have to write a Nix shell. Here we have Nix embedded into a Python file. So normally you'd have, right, user bin and Python 3, right? What we can do instead, at least for Linux and Mac OS, is we can say user bin and Nix shell. And we can tell it, hey, this script should run in a Nix shell with Python 3, and it should have NumPy in it. And I want the packages from version 21.05 of the Nix packages ecosystem. So I want packages from this exact moment of time, and I want to have Python 3, and I want to have NumPy. So now if we go in here, I'm going to exit this Nix shell. If I go in here and I tell it that I want to run this, it says, okay, you want that package? Cool, it'll fetch it, grabs it from cache. There's the version. Okay, what's another Python package that we could import? We can't do Swagler, sorry. It's a package that you made. No, it's an issue with you. Anyone got packages that people actually use? Yeah, anyone? What's that?
How do you spell it?
NetCDF. Is that a common package?
No.
We can try it. How do you spell it? Like this? Okay, Ben's gonna check it real quick. NetCDF. Oh yeah, we got NetCDF4.
NetCDF4.
Okay.
Okay.
Cool. So you want NetCDF4. How would I typically use this? So could I go import NetCDF? All right, chill. Do you need the 4? Oh, you do need the 4. Okay, excellent. We can manage that. I can hack that. Let's see how bad this is. Okay, here we go. So now it's told it, hey, we need NetCDF4. We're going in. No module. Okay, so what's the module? Maybe it is just NetCDF. Okay. Now this is the type of issue that the programmer needs to solve. Okay, so as you can see, we already downloaded the packages. Hell yeah, there we go. Yeah. It's in our environment. It's literally that easy, right? Someone told us a package. Yeah.
You see all that stuff that you downloaded.
Yeah.
What if like our system system already had that. Would it like download it again and again?
No, that's actually what we just saw, right? So we ran that CDF, we ran meta.py up there. It downloaded everything. We got an error. We changed it. We ran it again. It didn't re-download.
No, my question is, what if like you see open SSL in the dependencies?
Yeah.
So what if you already had open SSL?
Then it wouldn't re-download. Yeah, Ben, you want to get into that?
So the reason why it looks like it's re-downloading things is because it has complete dependency specifications. So if your OpenSSL differed slightly, like now versus Nix packages from 21.05, it's going to have to re-download it because it doesn't know that these are related or similar.
The thing though is, right, if you use this version, right, because of these hashes, right, because of these derivations, right, you get a hash. If that's the version you're using, if it has that hash, you're set. It's not going to re-download.
But even though the other version will be compatible with this.
Right, but that doesn't prove that it'll work.
But it doesn't, it's compatible with this.
No, but it isn't. That's the whole thing we saw, right?
Fun fact, some distros like Debian go quite to great lengths to try to maintain ABI compatibility, and they have ad hoc heuristics for doing this. But in general, it's a very flaky thing to do because, like, yes, you can declare your API and use semantic versioning, etc. But you can't, in general, know that the behavior of two things, two versions of a package will be the same. So the best solution is just to not do that.
Yeah, and if you work with hundreds of interdependent packages, like I'm part of the robotics team, we compiled this thing called Robot Operating System for Mac OS. This thing has hundreds of just top level dependencies, which means that you have thousands of dependencies going up all the way to the top. These package people, they change stuff all the time and they say, listen, it's backwards compatible. It never is. The stuff breaks all the time. And being able to have something like Nix, where you can say, I want packages from this state of time and nothing else, and that being how it works, is really, really powerful. So that was cool. I'm glad that worked. Let's see. So it's not just Python, right? So Nix has support for so many other languages that you can work with, and we'll be exploring that more later. But pretty much any language ecosystem you want to work with, it's in there.
So in particular, we actually want to show something that came up in our CS curriculum here at Vanderbilt. We have an operating systems class, and one of the things that you have to do quite regularly for the labs is cross compilation. So this is where, so briefly, there are some terminology, I guess. The build machine is where you build your package. The host machine is where you run it, and the target machine is, if in the case you're building a cross compiler, it's the machine that you generate code for. So in the usual case, your build and host machines are the same. So you're compiling hello world on your machine, it runs on your machine. In the operating systems class, you cross compile hello world. So your build machine is something like x86 Mac, and your host machine is maybe ARM64 Linux or ARMv6L or whatever. So the build and host machines differ. And this is actually seamless to do in Nix because there's a lot of cross compilation infrastructure. So the current solution in the operating systems class is to install VirtualBox, install Ubuntu on VirtualBox, then fetch the ARM None GCC ABI compiler, and you get different versions each time. Some people have different versions of Ubuntu and whatnot. With Nix, with this infrastructure, it becomes very seamless. So, okay. So this is actually what it looks like. So in a similar way, we have Nix packages here. Just maybe a slightly different hash. Here we can specify that we want the ARM embedded packages cross. So this is just something internal to Nix packages where there's a packages cross package set, and there's various pre-built packages like ARM embedded. There's even WASM or NetBSD, Windows, and so on. And here we're specifying that we want to have a shell from the cross packages, and in fact, the shell also includes the host compiler. So this is the compiler, say, for x86 Mac, running on x86 Mac. And we want the man pages for Linux, let's say. And here, I'll get to this one in a bit. So actually, we'll show some examples of how this goes wrong when people don't have.
Oh yeah, of course.
Such a solution. So we're actually going to open up Piazza now.
Yeah, Piazza's our forum for non-Vanderbilt students, for people to ask questions. We're going to leak some questions now. Get ready. So this is a person who tried to, make their code, okay, and fails. And then the instructor's like, listen, your GCC library path is wrong. So go into your machine and find the right path and use that instead, which is difficult to understand, especially like this is, a 3,000 level course. A lot of people don't know what libgcc even is. let alone know what this path is, right? Because this is a Linux path. This person's building on Mac. Then it just doesn't work.
This path may not even exist if this person.
Yeah, if this isn't the version that they downloaded, then this path that the teacher gave is going to be wrong too. It's completely unreproducible. And then here's just a guide. This one's just sad. It's just VirtualBox, right? VirtualBox has a lot of overhead. You're using apt, which is notorious, especially like if you run the wrong command on apt, like if you run like apt auto remove, sometimes you'll destroy your kernel. I actually did that last week. I ran apt auto remove and it removed the kernel of my operating system, which I needed that one apt, but whatever, I guess. Stuff happens all the time, right? This person tried doing a virtual machine and the teacher just said, I hope you push code regularly, which is not a great solution to that problem. So Ben, take it away.
Yeah. So how about we enter the Nix shell for operating systems?
Absolutely.
Right.
So we've got a Nix shell here. Actually, I can show you guys right now. So normally the compiler name is arm none. I got nothing like that. I got no arm packages here, right? So now I can run Nix shell, shell.nix. Let's give it a second. Get rid of this. Let's give it a couple seconds, okay? And now I've got an ARM compiler and I have normal GCC. So I can, and this is something that you need for operating systems. You need to be able to compile both for your own operating system and for this Raspberry Pi, which has, an ARM processor. So now we've got both, and I can actually show you guys. Actually, you know what? You know what we're going to do? That's what we're going to do. We're going to enter a pure Nix shell. And basically what a pure Nix shell is it takes nothing from my path. So it only uses Nix packages, which means that your environment is entirely reproducible. So actually, if I go in here now and I echo my path, every single thing in my path is from this Nix store. And if you run this Nix shell on any computer, your path will look exactly the same, which means that everything you run will work exactly the same, no matter what computer you're on. Even, I found this really cool. Even Bash, the terminal I'm using right now, comes from Nix. It's not using my macOS terminal.
You see the macOS terminal is 3.2, which is like severely outdated.
This is version 5.1. It's using a completely different everything. It's using something that's standardized. It'll work everywhere. Oh yeah. There's the libgcc. If anything changes, that environment variable changes with it. It's just simple as that. All right. So we have programming languages classes here. And one of the programming languages classes that we have is teaches Racket. You might have heard of it as Scheme or Lisp. Like obviously there's some differences, but they're, at least in terms of the class, in terms of the things that we actually learn and do, they're used pretty much the same. Now, when you have to write code in this, you have to install this IDE called Dr. Racket. It's over 1 gigabyte. It's not a great IDE. It hogs memory. It's kind of ugly. It's not great. Now, you have to install this thing. It installs in a bunch of different places on your computer. It's not a great IDE in general. People don't really like it. But here's the thing. It doesn't need to be that way. You want to pull it up?
Yeah.
So if you want to try out a programming language, I'm gonna exit that shell first. Let's say you just want to try it. So we're going to do Guile, which purposes of class pretty much the same thing. If you want to use a package, you want to try out Rust, you want to try out Racket, you want to try out Lisp, just go Nix shell. What package? I want Guile. We have Guile. We can do anything we want.
Yeah.
Now we have full access to package, and the moment we exit the shell, it's done. And we can remove it completely from our Nix.
Funnily enough, you have Guile pre-installed.
I actually do have Guile, which is really strange. The reason I have it is because of some random brew package. Again, this is why Nix is so important, right? So I do a bunch of robotics development. I have these thousands of weird brew packages on my computer, and one of them happens to use a Lisp interpreter for some reason. No idea why. And if I ever want to do something in Lisp, I can't change that interpreter version. I can't uninstall and reinstall it because some other random package uses it. It's completely unusable. I don't need to worry about that here. Because
Okay, so I just entered a Nix shell. You probably don't have Shea scheme. Let me just check that, unless you've been experimenting with a lot of scheme.
Right.
Okay, yeah. So in a normal shell, he doesn't have a scheme command, but now we entered Shay scheme. I just did that. I didn't even have sudo access to this computer, right? So you can do unprivileged, essentially package management, which is very nice because you get used to doing sudo apt this, sudo apt that, and you can script your system very quickly if you do not.
Sudo's a powerful command. You can do anything you want. It's dangerous, right? All right.
Right. So Nix actually started as a research project around maybe 15 years ago in the Netherlands, but industry has definitely picked up on Nix, and several companies in industry are using it now. One recent example being REPL.it. So it's a website where you can go and run, try out different programming languages essentially with their web IDE. They usually, in the backend, they had this very large Docker image, and it was essentially unmaintainable for them. And they recently switched all the infrastructure to Nix. And in their blog post, they announced that they can users can access now over 30,000 OS packages instantly. So DE Shaw, a very big company, they have this very glowing review of Nix saying that we think Nix is one of the few technologies left in the world that's extremely powerful. We think it's too good to be anything less than a de facto standard for packaging software. And other companies like Channelable have replaced ad hoc development setups completely with Nix as well. And other well-known companies like Mozilla, Tumblr, Atlassian also use Nix for their infrastructure.
What I find really funny is REPL.it is it's a website where you can try out programming language. The point is that it's supposed to be a low barrier to entry. What's funny is now they're using Nix. You can literally do the same thing. You just open a Nix shell with whatever language you want to try, and then it's just there. It's literally the exact same thing they're doing. It practically makes their service obsolete. You can just try something out, doesn't affect the rest of your environment.
One topic I'll touch on briefly is NixOS. So Nix is a package manager, and NixOS is the distribution, the Linux distribution. It takes the Nix philosophy essentially to the extreme. And it says, what happens if you allow yourself to configure your entire operating system with a configuration file? So you can declaratively specify if you want printing, sound, or your name servers or services running. It's completely declarative. And if you screw up your boot system, you can roll back instantly. So there's no issue of, oh, I changed something in my bootloader settings, now I can't boot. Well, you can just simply do symlink change and you're back up.
Okay, we got one more demo for y'all today, and it's something called Durenv. So Durenv is not actually specific to Nix. It's something that people use in general. Basically what it is it sets up an environment for a specific directory. So you have this nvarc file, you can put different commands in it to, like export this variable, add this thing to path, like whatever you want, right? You put that in the file, and then whenever you cd into that folder or you open VS Code in that folder, it automatically loads that environment into your workflow. And then the moment you cd out, it's gone. So that's cool. And with Nix, it's even cooler. So let me show you guys how this works. So let me exit this Nix shell. Okay. So right now, actually, we can go in here. So in the Python folder, I have this thing called nvarc. So the first line, again, you can run normal shell commands in here. So I just have an export, just sets a variable, just that way I can show you guys kind of how Durenv works. But then the second line, use Nix. And what that does is it automatically loads your shell environment, your shell.nix, into your directory for use. So let me show you guys how that works, because it's really cool. So if I go into Python, right now, Durenv is not approved, so I need to allow it. So we're going to use Nix. Let's give it a second. Okay. And now, if I echo that variable, so it's in env, you can see that it's true. I cd out, it's gone. cd back in. We're back. Oh, nope, that's the wrong command. We're back in business. And what's really cool about this is Durenv automatically reloads. So I can go, let's say, can someone give me a different Python package that isn't Swagler's? No, that's another one of your Python packages, buddy.
No, TensorFlow, please.
No, stop. Let's do requests. That's pretty chill. Y'all are too crazy. You know what?
Illusion of choice.
Exactly. I want to give you the illusion that you matter, Adi. So, oh, sorry, that's my unreleased version of Python. I can't tell anyone about that. So if I try to import requests right now, it's not there, right? I go in here, I tell it, hey, I want requests now. Okay, it's chill. Duren will automatically reload and say, okay, something changed. Your environment needs to be refreshed. Okay. It wants to give up. We're not so easy. There we go. Request is in our environment.
So why is this Siraphob using some other solution to install requests?
So the reason that, no, it's a fair question, right? The reason that this is better is because, especially with a package like request, different packages or like different projects require different versions, right? So if you need a different version of request for different projects, the point here is the moment you enter that project in VS Code, you have the exact right version of request that you need. If you go into a different folder, a different project has the exact right version of request that you need, and they won't interfere. Virtual environments are really messed up. Now, let me actually show you guys. I can show you guys right now. These are all of the versions of Python I have on my computer. I have base conda, I have OpenCV conda, I've got this, I got one from my friend Sean. I got M1 Python, I've got Intel Python, I've got base Python that ships with my Mac, I've got base Python 2 that ships with my Mac. There's so many goddamn versions of Python. And when I try to install a package onto this thing, oftentimes it fails. There are multiple packages that I have installed with pip or like in different virtual environments that literally do not work on my computer anymore because my path is so broken. Because there's so many versions of Python, and VS Code gets confused with this stuff all the time, right? Like this list, I have to remember which one to use. And oftentimes autocomplete doesn't use the Python version that VS Code thinks it should use. So then it gets completely confused into a different one. It's impossible for a system using Nix to get confused, especially if you use a pure shell, because like we showed you guys with the path, right? The only things in the path are from the Nix store. There's literally no other versions of Python. Nothing can trip you up. It's the exact packages and exact versions of things that you asked for. That's what makes this stuff so cool.
We demonstrate Python here, but it actually extends across different language ecosystems. So especially when you're working with multi-language projects, this scales very well because language-specific package managers excel in their own domain, but they don't compose very well. You can't try to have a lock file that locks the pip packages simultaneously with the cargo packages, with the cabal package, let's say. With Nix, you can do such a thing. You can have arbitrary number of languages in your project essentially, and they will compose. You're fixing committed Nix packages, which represents like the state of the world at that point. So there's no chance for dependency confusion in time or in the file system.
Yeah, and you'll see that also a lot of these language specific package managers, right? Oftentimes they come as a bit of an afterthought, even on languages when they don't really. You see this obviously in Python, right? Like pip is not great at resolving dependencies a lot of the time. And Rust, like they put a lot of work into that package manager and it still doesn't work well with a lot of people's environments. I currently have issues where if I open my terminal in certain ways, cargo doesn't work. Like I can't install packages. It's really weird. And it also wouldn't be a problem with Nix because I have a pure shell that gives me exactly what I need, exactly how it should be set up, which is why this type of thing is so useful. So y'all should get Nix. Thanks so much for coming. I hope you guys had a good time. I hope you guys learned something.